Okay. First thing I want to do is I got to test these caps. I'm not going to replace them if they're not bad. So I don't see any leaking. I'll put it on 20, the scale on 20. And I just want to kind of go through and test caps. I'm basically looking for open caps. My ESR meter and look at them as well. Looking for, these are all low voltage or low value caps, so I'm looking for, you know, 2, 3, 4, 5 ohms or something like that. Of course, if you see something like 30 ohms, then you've got a bad cap. The higher the value of the cap, the lower the ohms will be. So when I get to the 10 microfarad caps, it should go down to under an ohm, I would say. I think this is a 10. Or no, it's not a 10. That's a 1. This I think is a 10. Nope. I know this is not a 10. This I know is a 10. Yeah, see? Okay. And I think this is a 10, which I think this cap might not be any good. That's like the only off-brand cap. I think that's a 10. I'm not sure, to be honest. These are 100, so this should be a pretty low ohm number. Yeah. The only one that's kind of suspect is this black cap. And I really can't see it too well. I'm going to pull that cap, the black one, because I think that is a not so good cap. Got a new roll of solder. I'm about out of my thicker solder, so I got a new roll. You can find all of this in the links below the video in the description. I've got everything basically that I like to use is linked below. I don't recommend doing that, but yeah, this is a 10 microfarad. And it reads 8. So this is going to have high ESR. As the rated value goes down, ESR goes up. So this is a 10 at 25 volts. So this thing says that this should be around 1.5 ohms. Yeah, 4.2. So it's a little high on the ESR. This is out of spec cap. So I will replace that one. That's just how you hunt down bad caps. And you know what else? Let's look. One of these, I think these are 1s. 1. And I think this is a 1. I know this is a 10. These are all 1s. This is a 1. You know what I want to do is I got to remove this. I will remove these regulators because they got to get replaced. Voltage regulators, I always replace. It's just common sense practice. You just heat it up, then grab it. And if you can't, then you might have to just grab it with the needle nose. I want to remove those before I test these caps, because those ICs might be influencing the reading. They might have some internal capacitance. So now let's get a reading on these. Yeah, 1. That one's reading 13 microfarads. Is that a 10? I'm going to remove that because I don't think that's a 10. It might be. It don't look like it. No, that's a 1. Is there something on that that's influencing it? I don't know. Yeah, 1. So I don't know. I'm going to replace it anyway. I pulled it, so okay. So we had one bad cap, and these ones, I don't know why. Well, yeah, I don't know. I don't know why that one read 10 in circuit, but it did. Whatever. Okay. So and I don't have any more. I don't have no Q-tips. And I just restocked on my Chem Tech wipes, which are also linked in the description below. I always buy the 3-pack. Always. Okay. So I'll grab a 10 microfarad, a 1 microfarad. I'll grab a 7915, 7815, and we'll be ready to plug this baby in. So 8, 79, and a 1, and of course I don't have a 10, so I have to use an axial. I have to use an axial or a radial cap in place of the 10. Comment below if you like this format, if you like this way of doing this. This is the 1, goes right here. Okay. Okay, and this is the 10. Don't have to worry about it shorting on anything, that's good. Oh, it's a hot and humid. And let's put this like this. What are we looking at? Yeah. Seems to be working, doesn't it? Put that back like that. Free play. Well, the trackball don't work. It works going left, but that's it. If you go right, it goes down and back up. Yeah. Trackball. The trackball circuit is really fairly simple on this. So we need to fix the trackball circuit, and I need to replace these 40-pin sockets. I want to replace the 22-pin socket for the save chip. Let's put this in test. Yeah, that does not work at all. Up and down goes down. That's weird. Okay. I don't know if this thing is working or not. Let's try this. I'm going to turn it off, and I want to just flat out remove the save ROM, the rewritable ROM. I just want to remove that and turn it on. Do I get a message saying that it's bad? I don't. I don't know. That way, I just don't know if it's good or bad, to be honest. I don't know. It sure would be nice. I mean, what's that 4FF up there? I need to look at the manual for this and find out what everything means on this test. That's what I need to do. But we're going to replace the 40-pin sockets, the 22-pin socket for this chip. And then I need to read the manual and find out about this test. We can do the maintenance stuff first, though. And I can just go ahead and replace the two parts that are in the well, I guess we can try looking at it with the scope, see if we see anything goofy. That don't look good. Oh, okay, I wasn't on it. Yeah, that's no good. Uh-oh, what's happening? Oh, I was resetting it. Okay, those are the two caps where those signals go through, and they look fine. That looks good. Okay, that's not good. Alright, if this is one of the signals right there, that's no good. I don't know. I don't know. This one is going to be player 2. That's a 15584 or 14584. 14584. See how that changed that to that? But the output is still not doing good. So let's remove that and just bend out that last output, because it's being held. Now let's watch it. Still don't look right, does it? I don't even know if I got the pin out right. I'm sure I do. I'm just going to replace this part and we'll see what happens. Hey, what's up?
I'm going to do this.
Okay, I've decided to go a little more in depth with looking at what might be wrong with this. I got the schematic out, so. Of course, I don't have that part of the schematic. Of course. Of course. Let's see if I got it over here in this pile. No, I don't. Alright, I gotta go get the schematic. Okay, right here I am prepping to desolder, and that just consists of what I call cleaning the solder. I don't think that's something that I made up. It's just you're cleaning the solder. You're rolling your iron over all of the pads and loading fresh solder into it. And what it does is it just aids in desoldering. So that is what I'm doing right here, is just going down all of the pads and just freshening up all the solder. Makes it 1,000 times easier to remove. And right here I'm just using the flush cutters and my iron to pick all of the legs carefully out. I find that this is the easiest way to replace chips, is just to cut them out and then freshen up the solder so the legs will come out easy. As if you can burn up a board really easy if you don't freshen up that solder. It's very important. So yep, back to it. And you can see right here what I'm doing is I'm doing the exact same thing that I did on the back side, the solder side of the board. In prepping to desolder, I freshened the solder on the pin side. Now, in order to get a good clean desolder from my soldering gun, my Hako, I am doing the same thing. I'm freshening the solder from the top side, and you can see where I'm putting it over in a pool there, and that's all oxidized, used up solder, and it just cleans up the desoldering area that you're desoldering. Makes it so much easier with less damage, with no damage really if you do it right. Just clean up both sides of the board when you're done. here I'm removing the 40 pin chips in preparation of replacing those sockets. And now I'm going to do the same thing and freshen up the solder. And I'm changing my tip right now to my chisel tip, because the chisel tip is the best tip that I find for doing this process. And I'm going to go down the both the 40 pin sockets and refresh all of that solder on the solder side of the PCB. Okay, now after that is done, you can see where I had a clean spot on the board where I just kind of would pull that big ball of solder there. And that takes care of that. Now all of the back side of the board on the 22 pin memory chip and the 240 pin chips have been, the solder's been cleaned. And now I'm just going through and I'm going to go take a chance to clean everything that looks like it needs to be cleaned on the back side of this board. And after you do this, process leaves a lot of flux, so you always want to clean off all your flux. That's part of the process. Don't leave a bunch of flux on the board when you're using your Hako, because that will gum it up and clog it up. Now that the board is all cleaned up, it's time to get the Hako FR300. Mine is not the 301, mine is the older style 300. And get to desoldering. You can see here I'm taking the opportunity to clean out the barrel of the gun, and I do believe I replaced the filter here too as well. So that's what I'm doing right here, is just cleaning out this thing, make sure it gets, you know, good air sucking through it, so that it can actually do its job. All right, and the new cleaned out tube goes in with a new filter. Make sure you give a good clean to the tip. Make sure it's clear. Just like that. And then you're ready to start desoldering. Okay, and there's one of the 40-pin sockets down. It should pop right out, hopefully without much trouble. It looks like it's hung up on one leg, so I'm going to flip the board around and heat up that one leg, and it should drop right out. And there it is. There it goes. It's in the garbage. So now we're going to hit the second 40-pin chip. And that's the end of the second 40-pin chip. And that one came out a little bit easier. So, and that one's out. Now it's time to move on to that 22-pin memory IC. And now that everything is desoldered, it's time to just clean up the gun, get it prepped for next time you're going to use it. That includes cleaning the tip good like that, retinning the end of the tip,
and putting it away. And now we're getting ready to install the two 40-pin sockets, the 22-pin socket, and sockets up to the front of the board for the two chips in the trackball circuit. And now that all the socketing and cleaning is done, it's time to just repopulate this board and hook it up and see what we get. And you can see that I approve. That is a working trackball now. So it was just those two chips up in the top right part of the board. I just replaced both of them. The two suspects are the 14584 and the accompanying 74LS 157 MUX. I just went ahead and replaced both of those chips. And that is what fixed the trackball. Now we are going to turn our attention to this AR2 audio regulator power supply for the Centipede. And I cleaned this board up already. And now we're just going to look at it. It needs to be refurbed. All of the transistors and diodes like that need to be checked. So let's get to it. Here I'm checking the AC input diodes, And I'm looking for a typical diode drop in forward biased condition, and then I'm switching the leads to just check and see if I see a charge. When you're not forward biased, you should just see a charge going on the meter like that. So what you don't want to see is a dead short or an open. An open would look like 1 point some volts or something like that when you're forward biasing the diode. Now we've got it flipped over. I got this diode to check, and there's one more diode after that. Here I'm looking at this resistor. It's a 10 ohm resistor that gets burnt up due to the sense mod. So that'll have to be dealt with. And right here you can see I am just testing some caps. And of course they give off some kind of funky readings when they're in circuit, so I needed to remove them a little bit later on after doing some more testing, and they all tested fine, but I replaced most of the caps anyway, as you'll see. And right here I am just using the ESR meter to test these big capacitors, and this should be a very low reading, and you can see it is 0.02. That's right where they should be. So that's a very low ESR. Indicates that the caps are fine. Here I am going to be removing the two 10 ohm resistors that are in the sense circuit, because we're going to be bypassing that sense circuit and just jumping those 2 points. Here I'm using Amtech 559 Tachyflux just to prep all of your resoldering. That flux will help clean the solder that you flow into it, and just makes a better bond. I'm getting ready to desolder the 2N3055 pass element transistor, because we got to test that and make sure that it's not open, because if it is open on one of its junctions, then you will not get 5 volts. So I'm going to go ahead and remove that. I'm going to end up removing it right out of the board and testing it. You can see here I'm going to try testing this transistor in circuit after desoldering it, but if you saw the picture that I posted just a second ago, the bottom lead on that transistor was still kind of soldered and connected a little bit. So right here I realize I'm not getting a proper reading, so I got a little frustrated and just decided to go ahead and remove the transistor right out of the board. to test. When you're testing a transistor, you look for your two good junctions, and you always have to test between the collector and emitter both ways, with your red lead on the collector, black on the emitter, and then vice versa every time. And then if it passes, then it passes. And here are photos of prepping the transistor for reinstallation. Just heatsink paste on both sides. Now I'm going ahead and resoldering the amps, the two TDA 2002s, something like that. Resoldering those two guys. Now what I'm getting ready to do here is replace and test the PNP portion of this current pass element. This one biases, or it drives, however you want to say it, the 2N3055 current pass. So that's what I'm doing here, is just removing it to get a good test on it. Just remember, when you're testing transistors, always check between base or between collector and emitter with your leads both ways. Okay, and here I will demonstrate the proper way to test transistor. PNP, on the base you're going to put the black lead, and you're going to touch to the collector, get a reading, and to the emitter, get a reading. Emitter will always be a little bit higher of a reading. You can see it's 74 on the collector, 79 on the emitter. Now I just flip the leads, or I'm checking between the collector and the emitter both ways, and you should get no reading between the collector and the emitter. That's the proper way of testing a transistor. And now I'm going to be replacing the capacitors that I've removed from the board. That's the 470 microfarad caps on the 5-volt regulator side, and the 1 microfarad and 22 microfarad caps on the AC input, and the -5 and 12-volt regulation side. Here I'm just doing a little bit of cleaning on the top side of the board, getting rid of some of the flux before I insert the new parts into the board. I like to just tack the caps in from the top side so that they don't fall out when I turn the board over. So that's what I'm doing right here. Right about right here, I notice that there is a metal trace going in between the two through holes, and I'm using radial caps right here, and there's a danger of them shorting on that exposed trace. That's what I'm dealing with right now, and I'm going to end up removing those traces from the board here. And this is what it looked like after removing the traces. Now I can put those radial caps on there without fear of them shorting on that trace. Now we're going to tackle resoldering this bottom AC input section of the board. The two header connectors, and I'm going to resolder all of the big rectifying diodes. And at this point I decided to go over all of the soldering points that looked like they needed resoldering. So that's what I'm doing right here. And what I'm doing right here is desoldering the 7812 and the 7905 to replace. And now I'm going to be using some of the trimmed leads from the capacitors that I installed to install the jumpers in R29 and R30 to bypass that sense mod. And here I'm just cleaning the top side of the board to get any flux off the top. And then I'll put those leads through and solder them in. And right here I have found the exact same issue between the 470 microfarad caps, because I'm going to be using radial caps in place, and there's a trace going between the pads that are perfectly set for a short on my caps. So I'm trying to remove those traces, and I decided to stop and just put some Kapton tape down and heat shrink the legs of the caps. And now it's time to just do some resoldering on the regulator side of the board. There's 3 header connectors on that side that need to be done. And I need to put in, of course, the 7812 and 7905. So I'll be doing all of that right here. And for a good final cleanup, I like to use lacquer thinner because nothing works quite like lacquer thinner for cleaning this flux off of this board. So get plenty of Chemtech wipes and some lacquer thinner and a toothbrush and go to work. And now for the testing of the AR2, you can see it's cranked all the way up, and all I'm getting is 4.82 volts out of it. Otherwise, it's working fine. And since we eliminated that sense mod, we're going to have to make one more little modification on this board that I do towards the end of this video here. I was getting ready to end it, but I added a little bit onto the end, so stay till the end. And this is where this is just a little shaky. 4.8, and it's turned all the way up, and that is all I can get out of it. So the one modification that you need to do is this pot is a 1K pot. I'm going to replace it with a 2K pot, which will give me more adjustment. And that is the 2K pot right there. And you can see I started the pot right in the center, and you can see it's reading 4.20 volts, which is why it's acting funny. And now I'll be able to adjust it up to the proper 5 volts because I've got more adjustability with that 2K pot. So if you're going to eliminate the sense mod, I would suggest putting in a 2K pot so that you can get more adjustment. I believe the reason why it isn't getting up to 5 volts with the 1K pot is because the sense mod allows it to crank up more current and voltage to match what it's asking for. It self-adjusts. That's the way I look at it anyway. So yeah, there you go, 5 volts. And yeah, this multimeter has a bad connection or something inside of it. You have to hold the leads in to get a good connection. Yeah, it's no good.